All right, let's jump right into this explainer where we're going to explore our imminent return to the moon and the absolutely massive engineering and legal hurdles waiting for us up there. For over 5 decades, humanity has looked up at the lunar surface and dreamed of going back, and not just to visit, but to actually stay. Well, we are right on the precipice of a brand new era of space exploration, one driven by incredible technological advancements and really ambitious international partnerships. But as we prepare to leave our earthly bounds, we have to figure out exactly how we're going to survive up there, and critically, how we're going to govern ourselves. Because that question right there, that is the ultimate puzzle. Humanity is transitioning from over 50 years of just waiting to imminent actual execution. The sheer scale of what we are attempting requires so much more than just rockets and rovers. It requires an entirely new framework for how nations and private companies will operate side by side in a really harsh, unforgiving environment. So, we're about to look at the exact plans for how we'll build on the moon and the complex legal negotiations unfolding right now to determine who gets to claim the resources we find there. Let's kick things off with Section 1, the human element and our return to the moon. Our story actually starts with a very visceral human journey, NASA's highly anticipated Artemis II mission. 50 years. For the first time in over 50 years, 4 courageous astronauts are transitioning from intense training to mission-ready reality for a crewed lunar flyby. This isn't just a simulation anymore. These 4 individuals are enduring extreme physical and mental conditioning to test the brand new Orion spacecraft and the Space Launch System rocket. They're going to be pushed to the absolute edge of human exploration, venturing farther into space than any human has gone in half a century. But here's what's really interesting. This flyby, it's really just the catalyst for an even bigger long-term ambition, which is establishing a permanent moon base camp. Artemis II is the critical proving ground. By testing life support, navigation, and communication systems with an actual crew, we are gathering the necessary data to take the next massive leap. The goal isn't just to leave a few footprints this time around. It's to build a sustainable outpost on the lunar surface and an orbital station called the Gateway, which will ultimately serve as our stepping stone to Mars. Which brings us to Section 2, building a lunar base and the massive engineering hurdle standing in our way. Okay, so here's the crucial point. Building a long-term lunar outpost requires solving a complete logistical nightmare because shipping heavy raw materials from Earth is incredibly slow and astonishingly expensive. Every single pound of payload launched out of Earth's gravity well costs a fortune. If we had to launch every single brick, beam, and wrench required to build a moon base camp all the way from Florida, the Artemis program would literally be financially impossible. So we have to rethink construction from the ground up. To solve this, scientists are turning to ISRU. That's a highly technical way of saying we have to learn how to live off the lunar land. In situ resource utilization is the absolute backbone of our future in space. Instead of bringing our own building materials, we're going to use what the moon already has to offer. And the most abundant resource on the surface of the moon is regolith, that fine, sharp, incredibly abrasive lunar dirt that covers literally everything. And this leads us to a fascinating 3-step process for lunar-based manufacturing and construction. It's how we'll print structures directly on the moon, despite the immense challenges of low gravity and vacuum conditions. So, Step 1, autonomous rovers will harvest that lunar regolith. Step 2, we apply powerful energy sources, think solar concentrators or lasers, to melt the dirt down. And Step 3, we feed it into massive 3D printers using additive manufacturing techniques to build habitats, landing pads, and roads, layer by layer. It is a brilliant engineering solution. But it immediately raises a huge question. If we start harvesting lunar dirt, who exactly owns it? And that drops us right into Section 3, the legal frontier and the Artemis Accords. Because once we zoom out from harvesting lunar dirt and 3D printing bases, we hit a massive, overarching legal frontier. It turns out the laws governing outer space were written at a time when 3D printing habitats on the moon sounded like pure science fiction. Jumping from the broad 1967 Outer Space Treaty to the modern 2020 Artemis Accords shows just how far we've had to come. The foundational 1967 treaty established that no nation could claim sovereignty over the moon. Then, the 1979 Moon Agreement tried to restrict resource exploitation, but honestly, major spacefaring nations largely ignored it. Now, as NASA leads the Artemis program, they've introduced the Artemis Accords. It's a new framework, initially signed by 8 allied nations, designed to implement those older treaties in a way that actually allows for modern commercial and scientific operations. To make this work, the Accords introduce some incredibly novel legal concepts. First, they declare that space mining is not national appropriation. This is a massive legal clarification. They argue that you can't own the moon itself, but you can extract and use the resources from it. It's kind of like how you can't own the open ocean, but you're allowed to catch the fish in it. Furthermore, to make sure different countries or companies don't disrupt each other, say by kicking up harmful dust with a rocket landing, the Accords establish temporary safety zones around active operations. Now, as an impartial explainer, we absolutely must note that this framework has faced distinct international pushback. Major spacefaring powers like Russia and China have actually declined to sign. They've cited concerns over US-centric interests and unilateral space mining, arguing that creating these rules outside traditional UN processes favors American commercial interests. Essentially, they're worried it creates an environment where those who get to the moon first get to dictate the laws for everyone else. So, while the Artemis Accords aim to create a safe operating environment, the lack of universal global consensus creates a very complex geopolitical reality in space. Moving on, there's another really fascinating rule in the Accords, and that's the mandate to protect outer space heritage sites. Meaning, we will actively enforce safety zones around historical human artifacts, like Neil Armstrong's boot prints, to protect them from rocket exhaust plumes. Think about it. Because there's no wind or rain on the moon, those 1969 footprints are still perfectly intact. But the exhaust from a modern lunar lander could easily blow them away, which is known as the plume effect. So by designating these areas as heritage sites, the Accords are attempting to protect our shared human history from our own future progress. Let's move to our final section, Section 4, Updating Space Law and the Evolution of Law. This complex web of lunar mining, safety zones, and heritage sites brings us to a fundamental shift in how international space law is actually made today. We aren't dealing with abstract hypotheticals anymore. We are dealing with actual robotic landers and imminent human missions. So, we're moving away from the Cold War era method of anticipatory regulation, which basically tried to guess the future, and we're shifting toward a much more agile, adaptive governance. Back in the 60s, diplomats had to guess what space activities might look like and write broad rules to prevent conflict. But today, technology just moves too fast for that. Adaptive governance means we start with core principles, we monitor what operators actually do on the moon, and we adapt the rules step by step based on real-world feedback. And this adaptive approach perfectly mirrors the Hague Working Group's building blocks method. They use actual operational experience from commercial operators and governments to incrementally shape future multilateral rules. Instead of demanding a finalized, perfect treaty before anyone is even allowed to launch, this approach encourages transparency above all else. It suggests creating international registries so everyone knows exactly who is mining where, and it even proposes voluntary benefit-sharing funds. The idea there is to ensure developing nations also see the rewards of space exploration, with the whole system evolving organically as the industry matures. The International Law Commission really hit the nail on the head here. As they note, this flexible, staged approach is exactly how we update the foundational 1967 Outer Space Treaty for modern, commercial realities without having to completely rewrite the whole thing. By treating the Artemis Accords as a developing framework of bilateral agreements, what they call subsequent practice, spacefaring nations can innovate rapidly. But they remain rooted in the foundational principle that space is to be used for peaceful purposes. It's a really delicate balancing act between the need for commercial predictability and international harmony. So as we prepare to leave our earthly bounds and build this incredible future, this evolving framework leaves us with one profound, unresolved question that humanity absolutely must answer together. We have the engineering blueprints to live off the lunar land, and we have the early drafts of the legal frameworks to guide us. But as we harvest the wealth of the solar system, the ultimate test isn't just going to be how well our 3D printers work in a vacuum. It's going to be whether we can expand into the cosmos in a way that truly, equitably benefits all of humanity.